Well, good morning, everybody. Here we are for Chapter 19, Waste. I'm going to look at the issues of just waste that we produce and go from there. If you're taking notes for my class, once again, strongly encourage you, have the PowerPoint open on one screen, the video on the other, and then you can kind of follow along. So I'm just going to be going straight through the notes. Well, here we go. Section 1, solid waste. And your essential question, something to think about as we move through the lesson. What are some environmental problems caused by landfills? We need them. Once again, most everything has some sort of positive, some sort of negative, but what are the problems that are actually caused from landfills? All right, your first key term is the generation of waste. And that doesn't mean like your generation versus my generation. This means the production, making, generating waste. So we're going to talk about solid waste, if you will. Anything. This is like my junk mail or can that I use, or yogurt container, plastic, to a car, or anything that we actually get rid of, a bed, an old dresser. This is all solid waste. And every year, the United States alone generates more than 10 billion metric tons. Yeah, now you're going, well, what's a metric ton? Well, a ton is 2,000 pounds. A metric ton would be 1,000 kilos, or like 2,200 pounds of waste. That is every year, 10 billion tons. There's only 7 billion people on the planet. In the U.S. alone, we're making more than 1 billion tons apiece. It's shocking how much there actually is. The problem is a lot of things that we get today are, we buy it once and we throw it away. You buy this thing and it's gone. So it has tripled since the 60s. Now, granted, there are more people in America from the 60s, but still our per person waste has more than tripled since the 60s. So it's a matter of space. We've talked about that. The population is ever growing. So we need more land to produce wood that we're using. We need more land to produce food that we have to eat. And we need to have land that we can actually dispose of our waste on. It has to go somewhere. Imagine if you just had to keep all the trash in your own property, what you would do with it. They'd run out of space very quickly. It was funny, in 1987, a barge from New York had 3,000 tons of waste, just on a big boat. They were looking for somewhere to dump it. Nobody would take it. It sailed for it didn't sail, but motored around for 5 months, but nobody was willing to take it. They're willing to pay, hey, we'll pay you to take our waste. Nobody would. Ultimately, the barge went all the way back to New York, and then they wound up burning it, and they buried the then 430 tons. Pay attention to that. Started off as 3,000. Eventually they had to burn it, and then they were left with 430 tons, which they wound up burying where the whole thing started. Huge waste of resources, etc., everything. But that's part of the problem. It's getting harder to dispose of the waste we create because population keeps growing and we keep using more stuff. The average person in the U.S. produces about 4.5 pounds of solid waste a day. That means, your trash at the end of the day, you go to carry that thing out, about 4 pounds per person on average. Now, realistically, in a one day, it may only be a couple, but then during the year, you throw away a few big ticket items, like a desk or an old bed, a mattress, something like this, and that's kind of what brings the averages out to our 4 pounds a day. And here's the thing, not all wastes are equal. Basically, you either have biodegradable waste, like this paper bag, The paper bag, if it gets thrown away in a landfill or even the side of the road, eventually the bacteria, water hitting it, it'll break down and things will kind of eat it, break it down, and it'll go back into the nature. Because remember, it's ultimately came from wood, so when we put it back, it breaks back down and still can get reused, as opposed to non-biodegradable, like my paper bag. This goes in a landfill or I toss it off somewhere, it will break down. Now, it's still going to take a few months for it to completely break down, rot, be decomposed, but it will. This piece of plastic can't be broken down by biological processes. This one gets thrown in the landfill or tossed by the side of the road, and it remains there. The bacteria, animals, critters, worms, you name it, these decomposers, they can't break the plastic down. So it sticks around virtually forever. So anything that's plant-based, animal-based, these things are biodegradable. If we originally took it from a plant to make it, so even like if my shirt is made of cotton, well, it will eventually break down, rot, go back into nature. The paper bag, which I've thrown away already, will break down, but some things simply won't. But this newspapers, paper bags, cotton fibers, leather, these things are all biodegradable. Synthetics, however, are not. Things like polyester. Look in your shirt tags. Sometimes they're like 50% polyester. That's literally plastic. They're just weaving little fibers of plastic in when we make polyester clothing. Nylon, plastic, these are non-biodegradable. The thing is, these are made from petroleum. Oil products, it's a byproduct. When we refine the crude oil, that dark black goo, when we refine it, we wind up getting the plastics. And they combine in long chains. So for instance, we've made a little slime as a good illustration of it. This slime is basically one long polymer chain. Nature doesn't make this stuff. And this is what our plastics are largely made of. These long, continuous polymers. Nature doesn't make it. So nothing has evolved to eat it. It just sticks around. So we make our slime, you eventually throw it out. Fortunately, slime winds up being made from some, but once we convert it into this polymer product, it winds up not being very biodegradable anymore. And that's what plastic is. The plastic just sticks around forever because nothing really eats it. So these things last for hundreds of years. Realistically, we've only had plastics for about 100 years. It came from the discovery of crude oil, refining it to make gasoline, so along with the Industrial Revolution. So arguably the late 1800s, but widespread practice, only been around 100 years, and those things are still there. If you look at the next slide, it's a Yoplait, a old yogurt container, pitched out on a ship, offshore, was in a landfill, went down a river, who knows. Made its way into the ocean, washed up on shore, and yep, take a look, from 1976. But that thing looks brand new. Looks like somebody could have tossed it out a week ago. So yeah, when things are 44 years old, washing up on the beach, and they look like they're brand new, these things are not decomposing, and they're still going to be around a long, long time. So let's talk about municipal solid waste. This is waste produced by you and me and businesses. This is just what we do about our given day. We make this stuff, or we buy it and then we throw it away. This is what we call most of what we just throw out on a day-to-day basis. So I go buy my little honey bear, and when I'm done with it, I could reuse it, but a lot of times we just toss these things. Our as opposed to like the glass jar, which I can reuse and often do. But municipal solid waste, if I ultimately throw this in the bin, it becomes municipal solid waste. And it's growing a lot faster than, say, mining or agricultural waste. Both of these produce waste, but the municipal solid waste, that's what you and I are tossing in a trash can, and somebody has to deal with. It has to go somewhere, do something. If you look at the next slide, there's a nice little pie chart showing what it is. Paper is about 29%, give take. Food waste about 13.5%. That's something we really need to cut down. Yard waste, sticks, trimmings, clippings, cutting out a bush, things of that nature. Plastics about 12.5%. Of course, the problem with the paper, the food, and the yard waste will all decompose. The plastics aren't. Metals about 9%. Rubber, leather, textiles, wood, and then glass. Glass winds up a lot less of this, makes its way into the municipal waste because we reuse it. When it breaks, we have to throw it out, but a lot of times it does get recycled, reused. This is only 2% of the total solid waste in the US. This is just municipal. This is just what you and I are throwing out. And the next slide, this is a picture. Dump trucks just backing up to a huge landfill, dumping the trash. So if we look at solid waste from manufacturing, just a business producing milk, whatever. Mining, where we're getting our aluminum, gold, silver, salt, copper, sulfur, whatever. And agriculture, anything where we're raising food for profit, whether that's cows, pigs, chickens, corn, rye, barley, wheat, all of that. These all produce waste, if you will. But you and I, the consumers, because I want to buy my honey, we are indirectly creating the manufacturing waste. If we didn't want it, they wouldn't make it. If we weren't going to pay for it, it wouldn't be there. So when we purchase products that have been manufactured, we're indirectly helping to create it. Once again, if there's a demand for it, somebody's going to make it. If somebody makes it, but nobody's going to get it, they stop making it or put it in something that we prefer. Now, mining waste, so we mine, maybe this is the overburden, or we're getting the ore out. There's some copper in it, but a lot of it's just aggregate or this gangue mineral, stuff we don't need. And then we just kind of chunk it off to the side. It might be left in big heaps. We might dump it in the ocean. Once again, we just need to kind of get rid of it, out of sight, out of mind. Rivers, especially like if we're dredging, pull up the dirt, we just dump it right back in the river. And then it gets disposed by refilling and landscaping over it best we can. But this would be like mining, what it comes from. Most of the total solid US or waste that's produced in the US comes from these three: manufacturing, mining, and agriculture. We talked about that municipal solid waste, that's you and me just throwing it away, but that's only 2% of the total waste. The manufacturing, mining, and agriculture. Once again, you and I indirectly cause this because I want the copper, or I want my computer, which has copper in it, or I want lights, which have copper in them, or tungsten, so all that has to get mined. So then we have the waste from it. Now, agricultural waste, for the most part, are biodegradable. This is like grass clippings. Of course, if it's agriculture, it's the corn stalks, it's the wheat stalks, etc. Some of that can be turned into like hay. We can use it for animals, reuse it, or try and compost it in different ways. But the more fertilizers we use, putting chemicals, pesticides on it, then the waste can be harmful if we put it back in the ground. So even though a lot of the agricultural waste can be or is biodegradable, if we treat it too much, we're coming back to the same problem. We put it in the ground, the chemicals leach out, get into the water supply, and we get eutrophication, like my koi pond, which is hopefully getting fixed. But now we're going to transfer and look at landfills. This is just somewhere that we decide to put the waste. We find a county and we say, hey, we'll pay you money if we can dump all our trash there. And the county says, yep, good deal, we'll do it. And they provide a place and we pay them to dump the trash, and they take care of it for some reason, but it's permanent disposal. 55% give take of municipal and manufacturing solid waste winds up in a landfill. About 30% of our manufactured waste is recycled, which is good. It didn't go in the landfills. And about 15% of it currently is being incinerated. So it takes a big chunk and it makes it much smaller. There's still ash, there's still parts that don't completely burn, but it does make it a lot smaller, but takes energy to burn it, and a site for that as well. So even though it's a possible option to reduce the solid amount, still comes with problems. The thing is, landfills have to contain the waste that is buried inside it. So basically we're taking all the waste, we're dumping it here, just like that picture of the big waste site, and we'll probably show a couple of images up behind me. We have to keep that waste from coming in contact with the soil and the groundwater surrounding the landfill. Because that water, we put all the trash here, it rains, and all that water goes through all the trash, and water goes where? Yeah, downhill. It's eventually going to make its way into creeks, streams, rivers, and the ocean. Or in Florida, down through the ground into our aquifer, which is our water supply. So we can't just dump the trash there. We need to do something with it. So typically what we do is we put a lining underneath it that traps a lot of this other stuff, like a filter. The clean water makes it through, but it traps more of the harmful stuff, the larger molecules. And basically, day by day, we dump trash for a whole day, and then we come and we throw dirt over the top of it, help it begin to break down and pack, and maybe even coat it with plastic so we get protected layers. So we don't have this huge stack of trash where water can leak through the whole thing and collect up all these possible problems. What we get is leachate. Oh, you want to know what the heck is leachate? Well, let's take a look at an example of leachate to give you an idea of what happens. Now I got to go run, grab something. I'll be right back. For a demo here, I have my landfill. And then it rains on my landfill. So I have nice clean water pouring down on my landfill, and leachate. The water seeps down through all of my trash and just seeps down to the ground, and it begins seeping down into the ground, and it washes itself out either into aquifer, like here in Florida, or it goes underground under the bedrock, into the underground streams to fall into the water flow or make its way down into the ocean, or just kind of pours off the bottom of the landfill, goes down the ground once again and just forms into a creek or a stream, and there we go. Leachate. Right there. Now for me, fortunately, this is kind of a nice leachate. We'll just go ahead and add that to the old coffee cup, and I'm good to go for the rest of the lecture. That's some pretty good leachate there. But you get the idea. That's something I want, but now I'm going to throw my coffee grounds away, right? And they're part of it, leaching into it. If it's just coffee, it's not that big of a deal, but we're not just throwing away coffee. We might throw away chemicals. You may take some of your household chemicals, throw them out. You may grab something as, sorry, I thought I had one here, a battery, and throw it out. Oh, it's dead, you throw it out. There are chemicals in the battery, and as those metals break down and corrode, the acids leak out, and the metals are exposed, water goes over it, and now we're getting heavy metals into the ground. So you throw away paint. People are throwing away pesticides or things that pesticides have been sprayed on it. Just your cleaners, ammonia, Lysol, bleach, all these various things, little bits left over. And this is what's leaching through all the water. If the landfills are not monitored carefully, then the leachate simply flows out into our groundwater and can make wells safe to undrink, can kill fish, the whole thing. It's not hard to come up with what might be a problem. Another problem we have is methane. Methane will slowly leak out in from the landfills. Now it's getting generated in the landfill because as things decompose, just organic waste, things thrown away, whether it's a dead rat in there or deer or organic things that we throw away, methane is a product of the bacteria breaking it down. So it's under the ground. Methane winds up getting created when there's no oxygen there. The methane gets created, this gas then seeps out, and it's lighter than air. It's a gas, so as it rises up for the landfill, it follows little cracks along the seams, wherever it may be, making its way up and out. Now, if we know the methane's there and we create an area to trap it, or we throw these things in it, we can generate the methane, pump it off, and then we can actually use it. The problem is when it's getting produced and made and it's leaking out underground into areas and we're not aware of it. Then we get methane. So if this methane leaks out up into say something like your garage, well, yeah, you don't want a whole bunch of that in your garage catching fire, blowing the whole thing up. So it can be a problem if it's leaking into a home. So if we don't know about it, it does make big problems. Next slide show you just what might happen if you have methane in your house. Yeah, okay, that's a little extreme, but you get the idea. It's something we have to look for. We know it occurs, we got to watch out for it. So, the Resource Conservation and Recovery Act. Once again, in the 70s. In the 70s is where the EPA got some teeth. We're able to start making some laws, fines on these things. We updated in '84. Now, all new landfills have to be built with safeguards to reduce the pollution problems, whether it's methane, leachate, any of this stuff. They have to be lined with clay. Now, clay is a non-porous. Water doesn't seep through it, or very, very small. We line them with clay, we put a plastic liner, we have to have systems for treating the leachate. We know leachate's going to happen, so we go ahead and make an area where all the water is going to flow to. Now we can treat the leachate. We know it's going to rain, we know the water is going to come through it, so we're going to direct it to a specific spot so that we can treat it. Then we can have vents to lead off the methane so we don't have a problem with the methane, or ideally we can use the methane as a fuel source. So adding these safeguards though makes them more expensive, so we have to pay more for our trash to be taken care of. There's a cost with it, but we realize that human life and our environment is worth the cost. So here in America, we make sure our landfills take these precautions. If not, they're heavily fined. Along with that, finding places to build them is getting more difficult. Do you want a landfill in your backyard? And if it's a place that's good for agriculture, well, we don't want to turn it into a landfill. So the areas that we have are minimal, and we need to be able to put all these safeguards in place. The next slide just kind of takes you through what a modern landfill looks like. All the things that we take care of it. We got to find a suitable area that's kind of down that we can fill in, eventually cover over, and one day build something on top of it. That's the ideal plan. But where to get them? We're running out of space. The materials don't decompose as fast as we can fill them in. Once again, the paper, most of this stuff will decompose, but it takes a long, long time. Back in 1988, there were over 8,000 active landfills in the United States. But by 2005, it was down to 1,700. They were already filled to capacity. We don't have as many. Looking for new ones is getting harder and harder to do. What are we going to do with the waste? Now, incinerators. This is a good way. Remember, we talked about the one in New York, 3,000 pounds down to 400, or 3,000 tons down to 400 tons. A huge difference. In 2006, there was 103 of these that were capable of burning up to 94,000 metric tons a day. They're one option. We take everything that can burn, we run it through the incinerator, because even like plastics, they may not burn up, but they'll get smaller in size. But the thing is, incinerated materials don't disappear. If you've ever had a fire, you burn the logs, but when you're done, you still have some ash. Or you have a charcoal, you light the charcoal, you cook your hamburgers, but at the end you still have ash. It's a lot less, but there's still stuff there. So it doesn't just vaporize it, it doesn't go into nothingness, but it does minimize it tremendously. One of the problems, we burn things like our plastics here, well, it can actually be more toxic when it's in the atmosphere than just in this solid piece. So as we burn things, it releases the vapors into the air, and we got to deal with that. Now, fortunately, we have a lot of things that can take care of it. Like when we studied about air and air pollution in chapter 12, well, the scrubbers and the precipitators. Scrubbers are taking out poisonous gas. Precipitators are pulling out the carbon, the ash-like stuff. So we can rig these up in the incinerators as well, so we have the technology to take care of some of it, but not all. Once again, they're expensive. There's a cost. We have to run the incinerator, we got to buy the gas, etc., burn it. Then we have to treat all of the possible pollutants in the air. So it's kind of a whole big system. It's not as easy as, oh, we'll just burn it over here and then it'll be less. That can cause more problem than it's worth. We don't want to release mercury vapor, heavy metals, lead, things from paints into the air. Then people nearby are breathing it. Once again, respiratory problems, all kinds of issues from it. So this last slide is just kind of showing you an actual incinerator, all the various steps. So the trash can dump it in, then we have to take the trash out, dump it in, it gets burned. We can use that burning to create power though. Once again, we're boiling water so we can generate something from it, so we can generate electricity, pump the electricity off. Once again, we got to take advantage of everything we can. But then that toxic gas has to get scrubbed out to get the poisons out. Those filters have to be taken care of. Precipitators to pull as much of the smoke, just the ash, the carbon, hydrocarbons, and then we're releasing some of it up and we're carrying the ash back to another landfill. But 3,000 tons down to 400 tons. It's one of the things that we're looking to help us save space. Well, that wraps it up for solid waste section 1. Get your work done. Once again, you owe me a summary. Other than that, take care, guys. We'll see you next time.